you start 1A. Okay, no. No, little n is 2. Big N is what we're trying to find because we always know NA. Now the particles for this one happen to be molecules because this is a covalent compound. N is equal to small n times Na. So 2.0 moles times 6.02 times 10 to the 23 molecule per mole. Because MOL is on the top and the bottom, it cancels. So our answer is 1.204 times 10 to the 24. You got it. So that's how many molecules we have of ammonia. We only have 2 significant digits in our answer because this has 2. 2 significant digits here. We can't use Avogadro's number because it's a count. It has an infinite number of sig figs. So our final answer is 1.2 times 10 to the 24 molecules. Hydrogen atoms for 1 molecule of ammonia. So you can set up these ratios for any atom inside your molecule. We can use those now on our answer from A to figure out the actual number of atoms. So what you're going to do is you're going to take the unrounded number, the 1.204, multiply it by 1 nitrogen over 1 molecule, and do the same thing for hydrogen. Of ammonia. So if I multiply this by 1 nitrogen atom for every 1 molecule of ammonia, because molecules are on the top in the first value and on the bottom in the second value, they cancel. So nitrogen atoms are my final unit. So 1.2 times 10 to the 24 nitrogen atoms. You do the same thing for hydrogen. Take the number of molecules of ammonia. This time I'm going to multiply it by 3 because there's 3 hydrogens for every 1 molecule. Again, molecules on the top, molecules on the bottom, so it cancels. So 3.6 times 10 to the 24 hydrogen atoms. So here's one answer for C. Here's the other answer for C. The number of moles is question mark because it asked what is the amount. So we're looking for moles. So this must be big N. We always know Na. It doesn't change. The only thing that changes is the type of particle. Copper. Is it an element or a compound?
Element.
It's an element. So it's not one of our 7 diatomics. So Avogadro's number, the unit, is atom. So we've got two pieces of information now. We know NA and we know big N. So to find the answer, N is divided by big N divided by NA. 3.01 times 10 to the 23 divided by Avogadro's number. Half a mole. In terms of dimensional analysis uses ratios, like fractions, and when you set it up, you can only put multiplication signs in. So we're going to do a couple of questions using dimensional analysis. Magnesium nitrate is ionic, so the particles in Avogadro's number have to be formula units. Okay. So Avogadro's number would be this. Do you understand what Avogadro's number is? It's a number of things.
Oh, it's a really long number.
Right? It's just a really big number.
Like 23 zeros.
21 zeros, yeah.
Sorry.
So if I have Avogadro's number of donuts, I've got 6.02 times 10 to the 23 donuts. There's no way you could ever eat a tenth of that. If I have Avogadro's number of bananas, I have 6.02 times 10 to the 23rd bananas. That's a lot of bananas. Okay?
All the monkeys in the world.
So, yeah. I would be like the monkey queen. So, that is like a dozen. No formulas with dimensional analysis. So for this question, number 4, it asks, how many formula units do we have? So it's asking us to find formula units. I've only got 2 pieces of information. Do either one of these 2 pieces of information have formula units in them, in the units? Yes. The Avogadro's number is. So the very first thing you write down for dimensional analysis is the piece of information that has the unit that you want in the top. So, don't write this down yet. 6.02 times 10 to the 23 formula units of magnesium nitrate per 1 mole. So that's what I write first. Don't write it yet. Pay attention to what I'm saying and doing. So, the next thing you have to do is put a multiplying sign. That's the only thing you can put in. Multiplying sign. So we've used this number. Now we're going to use the other number. 0.21 moles. Now, if the unit is on the bottom and the top, it cancels. What are my units that are left? Give you a hint, they're right here. Formula units. Happens to be the answer that we're looking for. So when you type this in your calculator, you multiply any number on the top, divide by every single number that's on the bottom. So in your calculator, you would type 6.02 to the exponent 23rd times 0.21 divided by 1. Can only have 2 sig figs in our answer. So, we didn't use any formulas here. None at all. We just let our units drive our math. That's dimensional analysis. So we're going to do a couple of examples. So this is the information we have. We've got Avogadro's number, which is already a ratio, and we have the number of moles. So, we want to find atoms, so either one of those have atoms in it, it's got to come first. So Spencer, which one of those two has atoms in it? The second one. So 6.02 times 10 to the 23rd atoms per mole comes first. Then you put a multiplying sign. I can get rid of moles by using the other value, moles. So, in my calculator, all I have to type in, my moles are going to cancel. I'm left with atoms. All I'm going to have to type in is 6.02 times 10 to the 23rd times 0.0718. Divide by 1. Any number on the bottom, you divide by that number. Sometimes we're going to have different numbers other than the one on the bottom. What do you got?
I got 1.07156 to the exponent of 22.
Anybody else get that number?
That's wrong.
That's wrong?
That's wrong.
It is wrong?
I don't know.
I don't know. I don't have a calculator. What number did you get?
I got 12.3.
5.7 times 7 times 3, 7 times 6.
I could have typed it in wrong.
It's about 42, so it's got to be.
I might be wrong.
You're in degrees.
I could have typed it in wrong. Yeah,
Yeah.
I did get a wrong number.
Okay. That's okay. 4.322 times 10 to the 22.
That's a better number.
Okay.
It never works, so can I please use the window?
Sure. All right. How many significant digits can we have in our final answer? No? No? 3. 718. So 4.32 times 10 to the 22, and you didn't use any formulas. I want you to solve this question using these 3 pieces of information. You know 2 moles, you know Avogadro's number, and the particle is formula units. And you know how many nitrogen atoms are in 1 formula unit. The first ratio that you use has to have the units of your answer in it. So you start with nitrogen atoms. The units that I want, correct? On the top. I want to find nitrogen atoms. But now I've got formula units as well. So the next ratio I use, I've used this one, the next ratio I use has to have formula units in the top.
So we're not using formula units because it cancels out.
It's going to cancel it out. So our next ratio was Avogadro's number. So now formula units are gone. But right now I'm stuck with atoms over moles. I've got to get rid of the moles. So there must be something with a unit MOL in it. And there is. Now my moles cancel. So I'm left with nitrogen atoms. So in my calculator I've got 2 times 6.02 times 10 to the 23 times 2 divided by 1 divided by 1.
Why is it 2 divided by
Should be 2.4 times 10 to the 24. Okay, we're going to do another one. How many atoms of oxygen in 3.0 moles of CO2? So we're given this piece of information. We know Avogadro's number. The units are molecules because it's carbon dioxide. How many oxygens are there in one CO2? Yeah. So this is our other ratio. So there's one piece of information here. This is another piece of information. And then this is another piece of information. So out of those three, which one has oxygen atoms in it? Where does it say oxygen atoms? Last one, right here. So that's the one you start with.
She said second, she thought she said it was, I understand.
Okay, but I want to get rid of molecules because I want just oxygen atoms. So, is there anything there that also contains the word molecule? Avogadro's number. Molecules have to be on the top. Okay, molecules have to be on the top. That way, they cancel the unit on the bottom from the previous ratio. So now I've got 2 oxygen atoms per mole. I've got to get rid of moles. Well, I've still got a number. I've got 3 moles. So moles now cancel. My units left are oxygen atoms. Okay? So in your calculator, you would type 2 times 6.02 times 10 to the 23rd times 3 divided by 1 divided by 1. Okay? That's how you would do that. So